Okay, so in this lesson I want to look at the difference between combinations and permutations. And a permutation, another word for permutation is an arrangement. Another word for combination is a selection. So let me think about this question. It says, how many permutations of the numbers 1, 2, and 3 are possible? So 1, 2, 3, that's a combination of 3 digits. How many different arrangements, how many different permutations, arrangements can be made of these 3 numbers? What if we just think about this as 123 and we start to increase the value of the number as we go along? The next number would be 132, then 213, then 231, then 312, and then 321. So what I have is 1, 2, 3, 4, 5, 6 different permutations. It's important to note that all of these 6 different permutations, though, is just one combination. And if we remind ourselves of the fundamental principle of counting, to look at all the different permutations of the digits 1, 2, and 3, we break that experiment up into a series of 3 tasks. Task 1, choose a digit for the first position. There are 3 ways to do that. I could choose 3 or 2 or 1 for the first position. I'm arranging these. The number of ways I can complete task 2. Well, how many digits are available to me now to choose for the second position? Task 2 is to choose a digit for the second position. I've already used a digit in the first position, so there will only be 2 digits left to put in the second position. And then next task, there will only be 1 way to complete the third task, which is to choose a digit for the final position. And 3 by 2 by 1 giving me 6. So there are 6 permutations. Notice 3 by 2 by 1 is 3 factorial, which is 6. You can see that written sometimes as I was given 3 objects and I had to arrange them, taking all 3 at a time, so that 3 permute 3 is 6. In general, n permute n is n factorial. Any number permute itself is that number factorial. But there are 6 permutations, so that's important. 3 factorial. I want you to keep that number in your head. That's how many different permutations there are taking the digits 1, 2, and 3. And it doesn't matter that it's the digits 1, 2, 3. I hope you can see that any 3 objects can be arranged in 6 different ways. Okay? Or can be permuted in 6 different ways. Fundamental principle of counting. I could have just written them out in a list. It's only a small list. Fundamental principle of counting, 3 by 2 by 1. That's what a factorial is. Or you can use your calculator, 3 permute 3. I'm choosing 3 objects from 3 objects and I'm arranging them in as many ways as possible. That's what that means. Choose 3 objects from 3 objects and arrange them in as many ways as you possibly can. Okay, there's 6 ways. Okay, so 3 factorial. That's going to be important for the next thing I'm going to look at, which is this idea. It says taking 3 letters at a time from the set of letters A, B, C, D, and E, how many permutations are possible? So I'm taking 3 letters at a time from the set of letters A, B, C, D, and E. I want to think about how many permutations are possible. One thing I might think about first is all the different combinations that are possible, taking 3 letters at a time. And if I go through those alphabetically, A, B, C, A, B, D, A, B, E, there's a few different combinations. A, C, D, A, C, E, there's another couple of combinations. A, D, E, there's another combination. B, C, D, B, D, E, there's another combination. And finally, C, D, E. Okay, if I write that list of combinations down, there's 10 different combinations. ABC, ABD, ABE, ACD, ACE, ADE, BCD, BCE, BDE, CDE. No 2 combinations here are the same. In other words, we have a different, in every one of those lists of 3 things, we have a different combination of letters. But if we're thinking about how many ways, so again, actually let me answer this bottom question first, taking 3 letters at a time from the set of letters A, B, C, D, and E. How many combinations are possible? That's it. There are 10 combinations possible. And the way we write that is we say the set had 5 elements in it, and I wanted to choose 3 of them, and I got 10. So 5 choose 3 is 10. Or actually in our course, the notation you see most often, it's written like that: 5 choose 3 equals 10. But that's what that means. 5C3 equals 10. That means 5 choose 3 equals 10. That's how we read that. Taking 3 letters at a time from the set of letters A, B, C, D, how many permutations are possible? Well, I hope you can see that each of these combinations can be arranged. Well, this is very similar to the first problem we had. If there's 3 objects, they can be arranged in 6 ways. So each of these combinations can be arranged in 6 different ways. For example, ABC can be arranged as ACB, BAC, BCA, CAB, CBA. The same combination of 3 letters, but just rearranged. They're different permutations. And I hope you can see that I could do the same with every single one of these combinations. I can arrange them in 6 different ways. So there's a big table showing all the different permutations. I have 10 different combinations. Each combination can be arranged in 6 ways. So the number of ways I can do this is 60. And the way we write that is we have 5 objects from which to choose. We're taking 3 at a time, and we're arranging them in as many ways as possible. So we say 5 permute 3 equals 60. Now, an important relationship here is to think about the connection between 5 permute 3 and 5 choose 3. And 5 permute 3 is just 5 choose 3. So to find the number of permutations, first I found the number of combinations, but then I multiplied it by all the number of different arrangements for each one, and each one of these combinations can be arranged in 6 ways. What's that 6 coming from? That 6 is coming from 3 factorial, if you remember from the first lesson. Another way to say that is 5 choose 3 is equal to 5 permute 3 divided by 3 factorial. In our previous lesson, we looked at the formula for 5 permute 3. In general, we said n permute or is equal to n factorial divided by n minus or factorial. So 5 permute 3 will be 5 factorial divided by 5 minus 3, which is 2 factorial. So what we're getting here is 5 factorial divided by, well, dividing by 2 factorial and then by 3 factorial is the same as dividing all together by 3 factorial by 2 factorial. Okay, so 5 choose 3 is equal to 5 factorial divided by 3 factorial times 2 factorial, which gives us a little formula. There's a little formula we can derive from this, because it doesn't take much imagination to extend that for n choose or. In general, n choose or is equal to n factorial divided by or factorial multiplied by n minus or factorial. Okay? And that's called my combination formula. That's my combination formula. Okay, so permutations, there's always more permutations than combinations. How many more? Well, it's the number of combinations multiplied by the factorial of the number you're taking at a time. Okay? So let me look at a couple of just really quick examples, types of questions that can come up. How many ways can I choose 3 students from a class of 20? Well, this is three students. The order is not important here. This is a combination. I'm looking for how many ways can I take 3 objects from 20 objects. That's just it. There's not arrangements. I'm not talking about permutations. I'm talking about 20, choose 3. Now that is usually written on our course like that, 20, choose 3. But following the formula, n choose or is equal to n factorial over or factorial times n minus or factorial. This will be 20 factorial divided by 3 factorial times 20 minus 3, which would be 17 factorial. Now this looks tricky enough, but actually you could solve this pretty easily. There's a lot of cancellation is going to happen here. 20 factorial is 20 by 19 by 18 by 17 factorial. 3 factorial is 6. So on the bottom we're getting 6 by 17 factorial. Notice the cancellation here. 17 factorial will cancel out. 6 will go in there once and in there 3 times. So actually what I'm getting is 3 by 19 by 20. Okay. 3 19s, well 3 10s 30, 3 9s 27, so 3 19s are 57. Double that, 114 multiplied by 10. 1140. I didn't even need a calculator. I could use a calculator, type in 20 factorial. I'm doing it now, so do it with me. 20 factorial, find your factorial button. It's the shift function of the x to the power of negative 1 key, all over 3 factorial times 17 factorial. And you're getting 1140. The easiest way to do it, though, is just to type this into your calculator, which is 20, and the shift function of the division key is my choice. 20 choose 3 equals 1140. So I need to be able to work it by hand, but I also should know how to put it into the calculator. Sometimes these things you'll be able to work them more quickly out by hand. The key thing to understand there is we're choosing 3 students from a class of 20. The order of them doesn't matter. Anne and Barry and Charlie are the same 3 students as Charlie and Barry and Anne. No difference. Look at how that question differs from this question. 20 students have a race. How many ways can the positions first, second and third be filled? Well, in that case, if Anne came first and Barry came second and Charlie came third, that's a different result than if Barry came first and Anne came second and Charlie came third. So we're talking about arrangements in this question. We're talking about how many ways, if I take 3 objects from 20 objects, how many different ways can I arrange them? How many different ways can they be permuted? So I'm talking about 20 permute 3. And that will be 20 factorial from our formula divided by 20 subtract 3, which is 17 factorial. Okay, and again 20 factorial, that's 20 by 19 by 18 by 17 factorial divided by 17 factorial. There's that nice cancellation that happens. But here it's 20 by 19 by 18, okay, which is 6 times 20 by 19 by 3 in the previous one. So actually it should be just 6 times whatever this is. 6,000s, 600s, and 640s. 640 is 240, so I think it's going to be 6,840. But we can plug it straight into our calculator. The shift function of the multiplication key is the permute symbol, so 20 permute 3 equals 6,840. So practice working these things by hand, but also make sure you can use your calculator to find these things. When you get to exam time, calculator will speed up the process. One thing, important thing to note, which we actually looked at a lot of these combinations back when we were looking at the binomial theorem, that if I take 20 choose 3, which is 20 factorial, divided by 3 factorial, times 17 factorial, that will be exactly equal to 20 choose 17. Because 20 choose 17 would be 20 factorial divided by 17 factorial multiplied by 3 factorial. And 17 factorial by 3 factorial is exactly the same as 3 factorial times 17 factorial. So 20 choose 3 is equal to 20 choose 17. If I was to formalize that, n choose or is always equal to n choose n minus or. Always, for any values of n and or. Or always has to be less than n. They both have to be whole numbers. Okay, non-negative whole numbers. Any number choose itself is always 1. Any number choose 0 is always 1. Okay, and any number choose a number that is 1 less than it is always equal to the number itself. And that's always equal to any number choose the number 1. Okay, these are all things we've looked at before. But the big thing in this class really is to remember the connection between, or the difference between, combinations and permutations. Okay, so we're in 5.2. You're going to start practicing a few questions from this section.